We'll do this one without solving the equation. Just going to find what the sum of the roots would be, just going to find what the product of the roots would be. So if the sum of the roots is found by taking negative b over a, and I got an equation where got my quadratic form here equal to 0. B is negative 4. I'm negating that, so positive 4. A is, this would be negative 1, right? Sum of the roots just going to be negative 4. Product of the roots, take c over a. C in my quadratic is 7. A again is negative 1. So product of the roots is simply negative 7. That's simple. Okay, let's make this a little more interesting now. Let's find c in this quadratic equation if the roots are already given. So we've got a couple of irrational roots here. Okay, if I'm going to find c, I need to think about how c kind of works into the mix here with this sum of roots and product of roots idea. C has to do with the product, right? So if I look at the product of the roots, the way this quadratic is set up, that would involve me looking at c over a, right? Well, what is c? C here, right? C is what I'm looking for. And what is a? A is 1. So c over a, c over 1 is c. That's going to represent my product of the roots. Knowing that the roots are 3 plus root 2 and 3 minus root 2, well, multiply those together to form that product. We know how to multiply these together. Right, we're just going to FOIL some stuff out. If I multiply the first, got 9. If I multiply the last, got minus. Roots would cancel, so 2. C, in order for this equation to produce these roots, would have to be just 7. Okay, if we want to find a in this function as it's given, another quadratic set equal to 0, we know what its roots are. This time they're complex roots. Well, let's see. Let's think about how a can work into the mix here. As far as how a could work into the mix, a couple of things we could do. Since a is involved in both a sum of roots and product of roots, right, we could go either route here. Since we know both roots, we could multiply them together, set them equal to c over a. We could add them together, set them equal to negative b over a. Since we did product on the last one, maybe we'll do sum on this one. With a sum of the roots, I'm looking at negative b over a. So my negative b over a in this case, b is 6, be negative 6 over a, which I'm trying to find. If that produces a sum of the roots, take my two roots, add them together. Got one complex number plus the other. For our convenience on this problem, some nice things happen, right? As you add through here, well, basically, you're just going to have negative 6 over a equal to, well, you got 1 and 1, 2, and what happens to the I root 3's? They cancel out, right? Because you got same variables, same roots, but you got opposite coefficients. So these will cancel out. Negative 6 over a equals 2. Multiply both sides by a. Divide by 2. And a is going to be simply negative 3. Okay, so what I'm going to do, I'm going to divide this up. For perspective's sake, I'm going to set up a sum of roots side our product of the roots side. So it turns out on this one that we do know at least the product of the roots, right? Because we know what C is, we know what A is. We know the product of the roots is going to be negative 21 over 2, because that's C over A. We also know one of the roots is negative 3/2, but we don't know what the other root is, so I'm supposed to understand if I multiply on that root, I'll use R for root. Right, negative 3/2 times R will give me negative 21 over 2 back. The other side, the negative B over A. If I set up that form, I'd have negative K, right? Because K is in that B position, over 2. Setting that equal to the sum. Oh, let's see. One of the roots is negative 3/2. I'm letting R be that other root, so I'm going to add on that R. Looks like I've got two equations here with two variables, right? Meaning there must be a way to put the two together somehow. Put the two together somehow to at least solve for one of those variables we need. What I would suggest doing, since this one over here only has the one variable, maybe solve that for R, right? We can figure out what that root is that's missing. We could insert that in over here. And once we insert that in over there, then we'll be able to figure out what K is. So going through over here, I've got negative 21 over 2 equal to, if I multiply that R on, this is just over 1. So it'd be negative 3R over 2. I mean, you could cross multiply here or just use common sense. The top parts have to be equal, right? So if the top parts are equal, what's R going to be? R is going to be 7. So now we know R is 7. Take 7, plug it in over here. Got negative K over 2 equal to negative 3/2 plus 7. Be nice to have a common denominator there with the 7. So common denominator is going to be 2. This would be 14 over 2. Putting together what I can, we've got negative K over 2 equal to negative 3 and 14 give me 11 over 2. Once again, could cross multiply or just use some common sense because denominators are the same. Negative K has to equal 11, so K is going to be negative 11. We found what K is.